Hello everyone and welcome back to another episode of Mr. A's Geometry Podcast. So this is part 2 of an angles addition for addition and subtraction. Now we're going to take a look at angle subtraction. So subtraction and addition are very, very similar. We're using the same steps. There's always a partition, a substitution, of course subtraction instead of addition now. But what changes is just the sequence of things. We need to do a little bit of work to set ourselves up for subtraction. Remember with addition, the very first thing we did was addition, right? We took our two things and added them together. Here we have a little bit more work to do first. The last thing we're going to do is subtraction. So let's get into it a little bit. Since this is angles, as always, I'm going to recommend that we label our picture, right? Instead of doing BAC, CAD, DAE, all this stuff, let's call this angle 1, angle 2, and angle 3. Let's talk givens and proofs. So what have they told us is true? BAD congruent to CAE. Well, BAD, that's this angle here. And CAE, that's this angle here. So if BAD is congruent to CAE, we're starting with small angles or bigger angles? Those are kind of big, right? They're already composed of different pieces. So that's a clue that we're doing subtraction. We're starting with something large. Now what do we want? Well, again, I'll use green to show what we want. And I will stick it over there. We want to know that BAC is congruent to DAE. Well, BAC, that's this angle here. DAE, that's this angle here. In other words, what I want to know that angle 1 is congruent to angle 3. Now, if you're watching this right after the addition, you might be thinking, geez, this is awfully familiar. I mean, it's the same picture. It's almost the same given and prove. They're just flipped. If you haven't noticed that, take a minute to look back at your notes. If you just reverse this given and prove, you're dealing with an addition problem. And that shouldn't be so confusing, really, because addition and subtraction are inverse operations, right? First you learn addition, and then you learn subtraction as the opposite or inverse operation. It's no different with geometry. So here we're going from large angles that we know. I want to get down to these smaller green angles. So it's clearly subtraction. How do you do it? Well, look at that top right angle, BAD. How do you get from BAD down to angle 1? You have to take something away. What is it? Angle 2, right? If you take angle 2 away, you're left with just 1. How about angle CAE? How do you get from CAE down to angle 3? You're going to take away 2 again. So that's what we're going to be doing in this proof. We're going to start with this large angle congruent to this large angle. We're going to take away the same thing from both sides and end up with 1 congruent to 3. So let's get ourselves started. We know already that BAD is congruent to CAE. These are the large angles, right? BAE, CAE. In subtraction, we don't want to just start with the subtraction, because if we start taking stuff away from this, it's not going to be clear enough what's left behind. If I just take a whole angle and take a piece away, we can argue a little bit about what piece is left. So to avoid that problem, I'm going to start by breaking those big pieces down into parts. Because if I have 2 parts and I take one away, then you're left with the other one. There's no argument, right? There's no confusion. So we're going to break the whole down into its parts. What kind of a step is that? Breaking the whole down into its parts. Partition. So that's how we begin with a subtraction proof. We're going to start here in step 2 and say, look, angle BAD, that is exactly the same as angle 1 plus angle 2. That's partition, right? I can always say partition. I also want to partition CAE, right? Angle CAE is congruent to angle 2 plus angle 3. And I'll do that in the same step. It's also partition, so there's no reason for another step. So again, all we've done so far is broken down the 2 large angles into their respective parts. Why did I do that? What's my next step? Remember, partition always goes hand in hand with another piece. Substitution. The only reason we ever do that partition step is so that we can replace either a whole with 2 parts or replace 2 parts with a whole. Right? In this case, we're replacing the whole with the 2 parts. So what we're going to do in step 3 here is we're really just going to rewrite step 1. But this time, instead of BAD, I'm going to write 1 plus 2. And instead of CAE, I'm going to write 2 plus 2. So what we're doing is swapping out BAD, the whole, for its parts. So I get angle 1 plus angle 2, congruent to angle 2 plus angle 3. Alright? And again, if you follow the colors, BAD is the same as 1 plus 2. It says so right here. So I replace it with that. I substitute it. And CAE, it says right here, is the same as 2 plus 3. So I substitute CAE with 2 plus 3. My reason here is substitution. Steps 1 and 2. Okay. Well, now I've got 1 plus 2 is congruent to 2 plus 3. What do I want to have? Let's just take a minute. Remember, we're trying to get 1 congruent to 3, right? So if I want 1 congruent to 3, I have 1 plus 2 congruent to 2 plus 3. So ask yourself, what do you need to get rid of? On the left, it would be nice if I could get rid of that 2, right? And on the right, I also want to get rid of that 2. Can I do that? Sure. You can always take something away from both sides as long as the thing you take away is the same. So before you do it, you need to just take a minute and say, listen, I'm going to take a 2 away from this side, I'm going to take a 2 away from this side. And that's okay, because what I'm taking away is the same on both sides. How do I know it's the same? Good old reflexive. And now we're basically done. I mean, subtraction is so beautiful because when you set it up like this, it just falls off the page. Look at these 2 lines. In step 5, all I'm going to do is take line 3 and subtract line 4 from it. Well, if you take this away from this, I had 1 plus 2, I take away 2. I just have 1 now. On the right-hand side, I had 2 plus 3, I took away 2, I just have 3. It's so clear that angle 1 is congruent to angle 3 because we took the time to break them up into parts. So now when we take away that 1 part, the 2, I'm just left with 1 congruent to 3. What's my reason? Well, that's of course subtraction. If you're numbering like I am, that's with steps 3 and 4. And we're done. Put a proof box, feeling good about it. So that's all you have to do. With subtraction, like addition, remember that you're always going to need a partition. And the reason for that partition is so you can do a substitution. So you can take, in this case, the wholes and replace them with the sum of their parts. This allows us to take away a part, and what we have left is really clear. If you want to see, just for fun, something that's kind of neat to do, is if you take a look at these 2 proofs side by side. Let me just grab this addition proof, and so that's that. Put 2 pages up here. So here's our addition, and oops, I need this right there. That's what I want. Forward. So here's the addition proof, and there's the subtraction proof, side by side. Now this might be a little too small to see on the screen, so if it is, take the time to print this out and take a look at it because it's really interesting. You're going to see that they have exactly the same steps. They both have a reflexive, they both have a partition, they both have substitution. One of them's got addition, of course, one of them has subtraction, but all of the same lines are here. Where the difference is in the order, the syntax, if you will. With addition, we go right ahead in the beginning, we do a quick reflexive step, and we're into it, addition. Then we have to take a little while to explain ourselves. Well, so, we do a partition, and then we do a substitution to get what we want. Subtraction is just the opposite. Patience is the name of the game with subtraction. We have to wait all the way till the end till we get to subtract. First we have to do a partition, we do a substitution with the large parts. Then a reflexive, and the very last thing is subtraction. But it's interesting to look at them side by side because the same steps are used in each proof. So I hope that this helps you. If you have any questions, of course, please email me or see me in class. Thank you, as always, for watching. Have a wonderful day.